Okay, so now what we're going to do is we are going to look at each one of these elements that make up the system and study it in detail. What we will do is we'll study first with the R element in here, then we'll take the C element, and then we'll take the I element. So if we move, perhaps I think might be a good idea to go over here. Yeah, but better yet, let's take a step back and maybe do it from scratching here, so that you can actually see. What I'm going to do is I am going to make some notes so that you can have it also. I'm going to say a new page, and then we will have this kind of paper. Why don't we start with the, let's see, why don't we say, here we say R elements. Okay, what is the main job of this element? Is to dissipate energy. Dissipates energy. Yeah. So let's put an example of several of these. What about if we have this element like this? It's a mechanical one. We can have an element like this, which is an electrical one. And do you remember how the element on a hydraulic system is? On a hydraulic system, if you have this kind of a thing, you have a valve in here. This would be a resistive element. Yeah. So let's write down the variables that we see here. On this element, you could have a force applied. In here you have like this. On this this one here, you will have a between the two ends, there is a voltage, which we're going to call it V sub R in here, like that. And in here, of course, we have the current I. What about this over here? In this case, we will have a difference in pressure, right, between those 2 points. We're going to call the pressure P, and of course the flow of the fluid is going to be Q. Yeah? So you have this resistive element on the mechanical version, the electrical version, and the hydraulic version. What I'm trying to tell you is that these three elements, although they are in different energy domains and they have different units, their job as a participant of an element on the system is always to dissipate energy. So what would be the equation that controls the behavior of this one? Let's just write it down in here. F is equal to what? No, B, and you put it times X dot, right? That's how that one is. This one in here, you say the voltage of the resistive element is equal to what? Is the current multiplied by the resistor, right? Right? This is very good. They bring memories from your electrical circuits class. See, in this case, the pressure in here, you have the same kind of thing that, oh, excuse me, it's just right. And there we go. That pressure is equal to some constant. I think in fluids you use the letter C, Cp, I remember. It's just so that I am consistent with that, although I would rather not use the letter C, but since in most books it's Cp times what? Q. This is how the resistive element on a hydraulic system works. Now, if this is true, isn't it true that we could build a block diagram like this that says x dot, it gets multiplied by b like this, and out comes f, right? You also build this one, and here you say, oh, here comes the current, and then we multiply by the R element in here, and out of here comes this voltage. Yeah? And then what happens on the side? You have the same structure. Q is here, gets multiplied by Cp, and out gets the pressure. So I'm just going to put some labels in here so that you make it easy to understand this. This is what is in. This is what is out. See? Same thing in here. Same thing in this is in here. This is out. In here. This is out. Yeah? Now, I am going to propose a different notation that would have the same information, but would allow us to use this automated approach. So, what I'm going to say is that I can have this R element like this, and the output of the R element in this case is the effort. So this is F over here, and this is X dot. So, consistent with what I just did up, this is into the element, this is out of the element. Yeah? And in here, I can have that this is the R element like this, and this would be the output of this is the voltage, right? So this is B. So R, and this, of course, this is what is going out, and this inside is the current I, and this is what is going into the element. Okay, and then I am going to do one over here. Same thing. This is going to be P, which is the variable that we get out of the element, and then the variable that we go in is Q, and then we have the representation of three resistive elements in different energy domains, with different units, but with very same structure of the equations, and following each respective physical laws in the respective fields. Okay, so what would happen if I actually write the equation a little different. If I write the equation a little different, like for example, I go and say, you say, well, let's just put the title here, say, if, you could say, if we write the equations, sorry for this handwriting, is difficult with the mouse. If we write the equations in the other form, in this form, like, let me tell you what form I'm trying to say. So in here we go and we say, okay, we want to write it like we say, for example, in this case, let's say x dot. I could write the equation as equal to f over b. Yeah. And if we do this, we can also write the equation for this one, for the R element. We could say, how about I write the equation that I is equal to b sub r 1 over r times b sub r. And this one, if we write it like that, q is equal to 1 over c sub p times p. If we do this, then it follows that my element is represented in a different way, because what goes out of the element now is the flow. This is x dot, and this is f. And the other one on this side, this is the R element, and what goes out of here, this is I, and what comes in is this one. This is b sub r. And this one on the right hand side, same thing, but in this case the output is q, the input is p. So what I would like you to take a peek is and make perhaps a contrast. Take a look at this. That one is totally related to this form. Yeah? But I will change colors so to make emphasis of what I'm trying to tell you. This one here, this equation is totally related to this form. What am I trying to conclude by doing this? What I'm trying to tell you is that the symbol and in the place where the causal stroke is placed has everything to do with the form of the equation. So whenever you have this one on this, you have this form, then this is the equation that belongs to this. Whenever you have this one, this is the equation that belongs to this. Or vice versa. If you have the equation, it must be that way. So the conclusion of what I'm trying to tell you about the R element is that you have the ability to express the laws of this element in two different ways. depending on which of the variables you have it as an output. But I would like to turn your attention now to the slide that I was showing you. See here, this is, if F is the output, you have E is 1 over R, you have this form. But if E is the output, you have F times R equals this. So that's what I was trying to say. Set it in a perhaps better way and with colors and everything. You see that the picture on the left hand side, what is the output from the R element? Is the red stroke. What is going away from the element is what the output is. And on the one on the right, what goes away from the element R is F. So you have the relationship, the one on the left, we have to have it as E is equal to R times F. But if we have the other one, we have most certainly F equals 1 over R times E. That is that situation. Okay? Now, what I would like is to turn your attention to the C element. Let's talk about the C element, and in order to do that, we'll do a new page over here, and we'll just create a new grade in here. Why don't we write down where it says C elements. C elements. Okay, what is the job of this element? The job of this element is to store potential energy. Yeah. Okay. Let's put some examples of this. Just as we did the 3 elements on the mechanical system, let's do the same thing for the C element. Obviously, in this case, we will have something like a spring like this, where we have the force like that. This would be on the mechanical system. On the electrical side, we will have like this. And what about on the hydraulic side? What is the model of a capacitor or a C element on the hydraulic system? Something that stores potential energy. Basically, is a tank, huh? Like this. Yeah. So in this particular case, what do you have? You have. Let's just go to this one, because on the both of them here we have the voltage across the capacitor, and of course you have the current, right, that circulates like this. Yeah. And in this case you also have the here comes Q, and in here will accumulate a certain pressure there. These are the variables here. Now, how are the equations of this spring? According to Hooke's law, you're saying that force is equal to K times X, right? That's what this says. This one, the voltage across a capacitor, it says this is 1 over C times the integral of I dt, right? This one here, the voltage of the resistive element, let's call it voltage of the hydraulic C. What am I saying? Voltage. I'm sorry. I meant pressure. I am misspeaking here. So this is the pressure is going to be 1 over C, the hydraulic C, the integral of Q dt. Let's just write the hydraulic system, I mean this mechanical one also. C is the compliance, so we could do 1 over C, the integral of x dot dt, see? And now we have all three the same. Now, just as I did on the R element, how does the block diagram of this looks like? And how does the bond graph model look like? So, in this case, you will have that. What is the input here? The input is x dot. What happens to this input? Gets integrated, right? Once. In Simulink, how do we represent it? Well, why don't we just do it this way? Gets integrated once, and then gets multiplied by 1 over C, and out comes what? F. So this is the block diagram of the C element in this notation. If we look at this one, the input is the current in here, and then you get one integration in here like that, and then you say this is the 1 over C, and out of this comes B, C. This one in here, the input is Q, gets integrated once, and then gets multiplied by what? 1 over C over here. 1 over C, wow. I don't want to, well, this is in general, but C is the capacitor, but in this, I'm almost tempted to make a difference, call it C mechanical in here. So you don't think it's the same C. C hydraulic. C hydraulic.